So this is the framework that we're going to be using through most of the discussions that we'll be having, at least on reinforcement learning, at least single agent reinforcement learning. And it's called the Markov decision process. This should sound familiar to you, Michael.
Well, you did say we were going to talk about decisions.
That's true. And we need a process for making decisions. And we're going to introduce something called the Markovian property as a part of this discussion. And I'll tell you exactly what that means in a moment. So I'm just going to write out this framework and tell you what it is and what the problem it produces for us, and then we're going to start talking about solutions through the rest of the discussion. So a Markov decision process tries to capture worlds like this one by dividing up in the following way. We say that there are states, and states are a set of tokens that somehow represent every state, for lack of a better word, that one could be in. So does that make sense to you, Michael?
Yeah, I think so.
Okay, so what would the states be in the world that we've been playing around in so far?
So the only thing that differs from moment to moment is where I guess I am, like which grid position I'm in. So
Right.
I feel like each different grid position I could be in is a state. Maybe there's a state for being successfully done or unsuccessfully done.
That's possible, but let's stick with the simple one. I like that one because that's really, I think, easy to grasp. So there are at least, of all the states one could reach, there's 4 times 3 minus 1, since you can never reach the state. Although we could say it is a state, we just happen to never reach it. So at most, if we just think of this grid literally as a grid, there are something like 12 different states. And we can represent these states as their XY coordinates, say. We could call this the start state as, say, 1, 1, which is sort of how I described it earlier. We could describe the goal state as 4, 4, and say this is how we describe our states. Or frankly, it doesn't matter. We could call these states 1, 2, 3, up to 12. Or we could name them Fred and Marcus. It doesn't really matter. The point is that they're states, they represent something, and we have some way of knowing which state we happen to be in. Okay?
Sure.
Okay.